All right, so today we're looking at one type of special right triangle, the 45-45-90 triangle. We also call it an isosceles right triangle. So let me write that over here. Okay, so 45-45-90 or isosceles right triangle. So what holds true for any 45-45-90 triangle is that our legs and our hypotenuse have a special relationship. So the two legs, they have to be the same because, again, it's isosceles. So the two legs we think of as x and x. And when it's isosceles and right, a 45-45-90 triangle, when the two legs are both x, the hypotenuse is x times the square root of 2. So this pattern will always hold because if we have any 45-45-90 triangle, it's going to be similar to any other 45-45-90 triangle. So that means that we can scale it up or shrink it down, but our corresponding angles will be congruent. The sides will be proportional, so in the same ratio. So if I'm going from leg to hypotenuse, then we're really multiplying by the square root of 2. And if I'm going in reverse, if I'm going from hypotenuse to leg, we're really dividing by the square root of 2. Okay, so let's do a few examples. So here I just have one big example, lots of different problems within it. So find the missing sides. So I'm going to look at this first row, and I'm just going to start by labeling the two legs as x. And then the hypotenuse as x root 2. Okay, so when I look at A, right, one leg is 18, the other leg will have to be 18 as well. And if I multiply 18 by the square root of 2, it just becomes 18 root 2. Okay, in the next one, I have a leg that is 20 root 2, so the other leg would be 20 root 2. And then I take that leg, I take that 20 root 2, and I multiply by root 2. And in doing so, right here, when I multiply the square root of 2 by itself, it becomes just 2. So it's the same as saying 20 times 2, which would get us 40. So this hypotenuse right here has a measure of 40 units. Okay, the next one here, one leg is 15 root 3. The other one is the same, 15 root 3. Okay, to get to the hypotenuse, I'm taking that 15 root 3 and multiplying by root 2. Let me write that out. So 15 root 3 times root 2. So the 3 and the 2 are going to combine underneath the radical and become 15 root 6. All right, so all of those were going from leg to hypotenuse. Right? The two legs are the same. Hypotenuse is a leg times the square root of 2. That's true for any isosceles right triangle, any 45-45-90 triangle. All right, next row. Here I'm giving you hypotenuses, and I want to figure out the legs. So I'm going to start off the same way. I'm going to label the legs both x. Your legs are always those perpendicular segments. Okay, so all the legs are x, hypotenuse, x root 2. So remember, to get to x, really all we're doing is we are dividing the hypotenuse value by the square root of 2. And then sometimes we have to rationalize when we don't want a radical in the denominator. So in my first example, I have 18, that's the x root 2 side. So if I want to visualize this, I can say, okay, well, that x root 2 side equals 18. Okay, and then I want to solve for x. So I'm going to divide the square root of 2. Okay, remember, hypotenuse to leg, we're dividing by the square root of 2. That's exactly what we have right now. But we don't allow a radical in the denominator position as our final answer, so we need to rationalize. So I multiply by the square root of 2 over itself, and that's going to get me 18 root 2 divided by 2. And then I can see that that's going to simplify to 9 root 2. So my two legs are both 9 root 2. Okay, if I want to double check going forwards, leg to hypotenuse, if I take 9 root 2 and I multiply by the square root of 2, that's like saying 9 times 2, that gets me back to 18. Okay, right here, I just want to point out a shortcut. So if I see this number right here is an integer value, so right here I see that it's 18. If I want to go from hypotenuse to leg, right, I need to divide by root 2, and then I'm rationalizing. So what's happening here in my mechanics is I'm essentially multiplying by the square root of 2 and dividing by 2 right here. So let's say that this was 10. I want to take half of 10 and multiply by root 2. That would mean that if this was 10, these would both be 5 root 2. If this was 12, so half of 12 and then times root 2, these would both be 6 root 2. So I'm just pointing out a pattern. All right, next one here. So if x root 2 is equal to 20 root 2, if I'm just dividing away that root 2, these would both be 20. But let me make sure you can see it if I do it longhand. So x root 2 equals 20 root 2. So again, I'm just dividing by root 2. And over here, I see that that's going to cancel away 1 to 1. I'm just left with 20. So the two legs are both 20. Okay, one more variation. So here in F, here I'm giving you that the hypotenuse is 15 root 3. So here, if I do my little shortcut, if I take half of it and multiply by root 2, it's going to give me a fraction. That's fine. That would be 15 over 2, and then times the square root of 6. So I know what these are going to be. Let me write that out. So 15 root 6 over 2. 15 root 6 over 2. And let me show you how to do it longhand. So again, if I have x root 2 equals 15 root 3. Okay, here I'm going to divide each side by the square root of 2. Okay, and then I'm going to rationalize. So I'm rationalizing the denominator by multiplying by root 2 over root 2, which is really 1. So on top, I have 15 root 6 divided by 2. Okay, so no matter what this number is, it's easier when it's an integer value like it was over here, but we can still do it the same way when we see that it's irrational. That just means that we have a radical in here. So I can take half of this value and then multiply by the square root of 2 to get me to these two positions, the two legs. All right, I want you guys to pause the video and I want you to practice the next 3 and then unpause, and I'm going to go over them. All right, so here we go. So this last batch of 3, let me just label the legs x. And then the hypotenuse will be x root 2. So remember that going leg to hypotenuse, we're multiplying by root 2. hypotenuse to leg, we're dividing by root 2, and then sometimes we have to rationalize. So I'm just going to remind you that another way of approaching it, if I'm going from hypotenuse to leg, is to take half of the value and multiply by the square root of 2. Okay, so looking at this first one, the other leg is 16. And then 16 root 2 for the hypotenuse. Okay, over here, I see that the hypotenuse is an integer. That makes my life easier. So I can take half of that, that's 8, and then multiply by root 2. So these would both be 8 root 2. Let me remind you of how you do that longhand. So if I'm visualizing that x root 2 equals 16, and then I'm dividing each side by the square root of 2, now I have 16 divided by the square root of 2. And now to rationalize, I can multiply by the square root of 2 over itself. So 16 root 2 divided by 2 confirms that it's 8 root 2. Okay, and then the last one here, right, I see it's a non-integer because I see that there is a radical for the hypotenuse. So here I can easily see that if I take here my hypotenuse and I divide by root 2, I would get 10 root 3. So 10 root 3. And if I just want to confirm that longhand, I can say, well, if x root 2 equals 10 root 6, and I divide each side by the square root of 2, that's exactly right here where that's coming from. And I'm left with 10 root 3. So root 6 over root 2 would be root 3. So I end up with 10 root 3. All right, so nice little intro to 45, 45, 90 triangles, or isosceles right triangles. A reminder that when we go leg to hypotenuse, we are multiplying by the square root of 2. And when we go in reverse, hypotenuse to leg, we're dividing by the square root of 2. And we know that we do not leave a square root in the denominator position. We don't leave any radical in the denominator position. We rationalize the denominator. Have a good rest of your day.